Please start. Yes.
Thanks for your presentation, Cristina.
Could you wait for the microphone so that everyone can?
I'm a practitioner, not a researcher. I work with secondary schools. Their big job in setting up learner analytics is, of course, getting the data, and so tracked data can be really useful. I'm interested in your eyeball tracking software. I guess it's a crystal ball question. I watched the transition in geographic information systems that happened 15 years ago as we went from very expensive paid bespoke things to using Google Maps, and all of a sudden it was free. You made a little throwaway comment that your eyeball tracking software was very expensive. What's your crystal ball? Is it going to go to be cloud-based somewhere?
So sorry, the software that we developed some software to create the features from the raw gaze data. What's expensive is the actual eye tracker. So, and there's a lot of work. There are a lot of people working on non-expensive eye tracking technology. I still haven't been able to find cheaper eye trackers that have the same performance of this type, the type that we use. But hopefully people will keep working and they'll get to having cheaper eye trackers that are also good, well-performing. So
yeah, all right. Just a clarification question then. Does your eye tracker rely on the user's laptop camera, or does it use other hardware?
No, it uses its own camera. Yeah.
From the user's laptop, or the
No,
no,
it's
got a dedicated
So
one.
this particular
Yeah.
one that I used, you get the whole monitor,
Yeah.
and the eye tracker is embedded in the monitor. The new version that Toby put out, which is as expensive as the previous one, but it's much more portable. So it's a bar that you can attach to any monitor, and at that point, that's the eye tracker with the camera. So yeah, no, but the camera is part of the eye tracker. So,
Okay.
there are. Toby has a cheaper eye tracker that is, I guess, in the order of 200 Australian dollars. That I'm told has very good performance, but is designed for games, and you're not allowed to use the raw data for research publications unless you buy the license, and the license is very expensive. So there's always a catch. So in the end, you still pay a lot of money. But so the one that I use and the new version, the actual hardware, I think now it's around, so I think it's 20K Canadian, so what, like 15K US, but then you have to get some of the software to do, so we actually don't need the software because we use our own software to create the features. But if you want to do any offline analysis, you also have to get the license to get your own software. And then at that point, it becomes more like 35K for that one that I use. For this new one that I'm told you just need the license, apparently the license is around $2,000. So it would be cheaper, but I am not sure about the actual accuracy and performance of the eye tracker itself. So, yeah. But so people often ask me, so if the eye trackers are so expensive, what's the point? You'll never be able to use them in educational settings, right? But to me, it's proof of concept that what you can do with this eye tracking data, and I have great faith that the people working on eye tracking technology will eventually come up with cheap eye trackers. So I know it's true. So when, I don't know, but I think for me it's important to show what you can do with this data, right? And there's this saying, eyes are the windows to the mind, and a lot of this research kind of speaks to that. So it's quite interesting.
So across the data that you presented, it was impressive on you used the eye tracking to predict the complexity of the graphs, right? And then that had a pretty high accuracy, very impressive accuracy. But when you were presenting on the individual differences, I was concerned, and I just want to know if you were concerned, on how low the accuracy is. So with accuracy of 60%, 65% is what I was seeing, which declines as a function of performance across the performance. Usually, I mean, you had some peaks, but it'd be hard to predict when those peaks are. I was worried about the utility of focusing on individual differences when, I mean, in a real life setting, you're not going to actually gather the individual differences. So it seemed that what was more important was capturing whether people were having problems, right? And not necessarily, it seemed like if I looked at that data, it was my data, I'd say, oh, okay, so we actually don't need to pay attention to individual differences because our accuracy there is low, but we can predict when someone is having a problem and then knowing that we should scaffold that in some way. And so some questions I thought were, okay, so eye tracking can predict when you're having differences. Maybe how do you compare that to just response time? Does response time help to predict it? You can gather mouse movements pretty easily or tracking movements. Does that kind of data, what source of data that's easier than eye tracking that you can gather through an interface help to just predict, oh, you're potentially having a problem, how can I help you? And then along those same lines, and this is more of a question too, is I didn't understand the utility of hiding something. So if I've got two things, it doesn't necessarily help me to hide it as much as get help. We know people don't ask for help, but providing the scaffold. So that I found a little confusing. Yeah. So just wanted your thoughts on all of those thoughts that I was having.
Too many questions.
Yeah, like those are my thoughts.
No. These are all great questions. So starting from the percentages, accuracies for these individual differences. So definitely agree that they're low. A couple of things to say. First of all, so these are like one-time tasks. So this is already the user of, actually.
Yes.
Yeah. So a few things. First of all, we didn't spend too much time refining the machine learning, right? Because we were really interested in just seeing if we, at least we can predict better than the baseline. And I know this is a very machine learning kind of talk. Just 2% higher. Who cares? No. But just the fact that you can, which is, surprising to some extent. But we didn't spend a lot of time doing some more digging in which machine learning techniques we could actually leverage to possibly bring the accuracies higher. Also, these tasks, they were like one-time tasks, right? So perhaps if we have more data, the users working over time, the accuracies could go up. That's another possibility. The other thing is we could also consider, even if the accuracy stayed relatively low, you're right, there are other triggers that we could use. And that's when I was mentioning this work that we have done on capturing confusion, right? Because detecting that they have problems is not necessarily as easy when they're looking at something, right? Because some users do follow their gaze with the mouse and others don't. So there's actually quite strong results about that. So for some users, you could rely on mouse movements, but not for all of them, because some of the situations are definitely not interactive visualizations, right? So rely on mouse movements, not sure. Okay, so the results for the first study, for instance, we did not have information on pupil dilation and head distance because we hadn't controlled for lighting of the room, and so you can't really use the pupil. So one possibility is that by adding that information, that could also bring the accuracies up, right? Then you could say, well, but in which situation you're actually sitting, it doesn't really generalize to real world settings because then you have lighting problems, so you will never be able to use pupil information. But there are people working on actually be able to process pupil information also in in the presence of light. So that's another thing that, in the long term, it's possible that pupil dilation information, which can be really important for, these kinds of tasks where there is even like cognitive load could have an effect. So if you can process that, if you can add that to your data sources, that could increase the accuracies as well, right? But the main point could be also look at other triggers for adaptation, including confusion, right? Because what does it mean to have a problem? For instance, you're looking at the visualization and you're really confused, which is what happens with some of these, users working with MetroQuest. They see there's two visualizations, there's just a lot of information, and they're confused. So we actually ran a study with a different visualization that I haven't showed you, where we collected data, we had users report confusion, and then we built a classifier for confusion detection. The problem is it was a fairly good visualization, so we did not have many points of confusion. We had enough that it's important to be able to catch them, right? But in terms of machine learning, when you have a very skewed data set, then you have all sorts of other issues. But we did have some good results in predicting confusion. So you could say that even if the percentages stayed low for individual differences, what you could use, you could have another trigger. Could be that you're predicting confusion, could be something else that you can get from the interaction that signals a problem. And it's good to know that there is a problem, but what the information on individual differences could tell you is how to solve it. Because I know I'm confused. Okay, fine, what do I do? Right? I know the user is confused. I know the user has a problem. It's great. I can empathize, but then probably we want to do something more than that, right? So the information on individual differences could help because you could say, yeah, this is, I'm predicting that is a low perceptual speed user. Perhaps what I could do is to help process the legends, right? The whole point is because the accuracy is not as high, you want to find ways to generate these interventions in a way that could be helpful, they're there, but they could be also ignored. Okay, so that's what you do when you have classifiers, when you have user models. They're never 100% accuracy, but they're not. If the accuracy is not high, you could get the system to kind of give its best bet and try to have an intervention that could be there as a suggestion, some helpful hint, or some highlighting that, again, it's not too intrusive so that the user can not use it if essentially the model prediction is wrong, right? It's not easy to do it, but that's how you deal with predictions that are not necessarily always accurate. And we have done this work with different research that we did on providing hints during, in ITS research, where, again, you don't really have 100%. Its accuracy is higher than this, but it's still around 75, 80%, so there's still some, false positives and interventions that are out of place, and you just have to make sure that the user can ignore them. They're not too intrusive.
One follow-up.
Yeah.
It has to do with reverse engineering. So you've got the data on the eye tracking, and in reverse engineering, if you got the data on the eye tracking, but you don't have their individual difference measures. So we've done some work like that, reverse engineering and predicting things like working memory based on language. And so is your thought that you'd have the data on the eye tracking, you'd have an algorithm that predicts that this is the behavior when you have a low visual processor, and then you would intervene in a particular way, not having, of course, the individual difference measure, but having the data on the eye tracking.
Yeah,
right. That's
Yeah,
That's your
yeah,
thought
yeah. Because the
process.
idea is that, I mean, you're in a setting where you can give the test to your users, then you actually know for sure if they have high or low perceptual speed, right? And then, but in many situations you cannot do it, right? So there's always that possibility. The tests are out there, and some of them are just a few minutes long, and they're online. So if you, for instance, have your student population and you want to create a dashboard that the students are going to use all year long, well, why not give them a test for these perceptual abilities, right? At the beginning of the year, I don't know. You can do that. So then you have the actual information, right? Then you don't need these classifiers. You still need classifiers for picking up when they actually have problems, because it's not the case that a low perceptual speed user will always be in trouble with a given visualization. So other triggers like detecting confusion, detecting some latency in response time, a trigger that tells you, yes, this is a good time and the user needs help now, you still need that, right? But this information on individual differences can make the intervention richer and more to the point.
I would also have a question, or several, but I will focus just on one. Your work resonates quite a lot with what I'm trying to do at the moment. My research is
I
about...
want to thank you because of your survey, because I didn't know a lot about the research and dashboards, and so I saw your paper, and I said, yes. So thanks for that.
Yeah, thank you. So my work is on adaptive learning analytics dashboards for learners. And one of the issues that I'm having at the moment is that in the beginning I compiled a long list of user characteristics or individual differences that could have an impact on how users or learners use visualizations and the dashboards. And my question is, how did you choose the ones that you focus on, and how did you settle on the number? Why did you go for, there were 4 or 5? Why didn't you go for 1 or 10? And do you think there's any interaction between these?
Yeah, so it's a great question, and it's you just put your finger on an issue that we often have. So, for instance, it was more than so. For instance, in the second part, let me just quickly find. So in the second study that I showed, where we're looking at those more interactive visualizations, the map and the deviation chart, we actually started with 10 individual differences, okay? And we had exactly the same questions that you had. So we knew that we wanted to use, oh, did I turn it off now? We knew that we wanted to use the first 3 because we had already evidence that they impact visualization processing with bar charts. So we figured, let me see if they also have an impact on these new visualizations, right? So that was a no-brainer. But then because we had a map, we had to go and look at the literature on which individual differences could be relevant, right? So my postdoc spent a lot of time going through the literature, understanding the definition of the different possible perceptual and spatial abilities, and in the end, we just picked these 2 because for various reasons, the others turned out not to be as relevant. And we have a perceptual psychologist in the group, and we also kind of asked him for advice. Because you could throw as many differences as you want, but then you just have way too much data and way too many different dimensions that you have to look at, right? So there's a lot of screening that you can do beforehand just to try to understand from the literature, if you can, what are potential good candidates, right? And then, for instance, here, there is this visualization literacy. I didn't show this slide during the talk. So visualization literacy, it's a new measure that has been proposed in the InfoVis community. A couple of years ago, there was this major conference, this information visualization, InfoVis. And these researchers proposed this measure that is supposed to be the counterpart of reading proficiency for verbal abilities, right? And there was no such measure before. There was no some general test to prove how good you are at processing visual information. So they proposed this test. The paper was accepted at the conference. They have a specific test that you can give users to get a score on their visualization literacy. We decided to try just because it seemed to make sense, right? But the test is not as well established as the other ones that we used. And in fact, we didn't find any effect for that. So we don't know if it's the problem with the test or I have no idea, right? But that's also, and on that side, so we locus of control, again, we put it in there because there are other results showing that that impacts other, working with other visualizations. Need for cognition is my personal favorite. I never find any effect for it, but I keep testing it because I think there should be. No? Feel it? That doesn't work? I'm still gonna keep trying. So it's a tendency to like effortful mental tasks. And I thought, well, here you're sort of like in a decision making where you're supposed to kind of, dig out for information and make comparisons. And I guess if you have a lot of need for cognition, well, anyways, we didn't find an effect, but that's the reason why it's there. I thought it made sense, right? And expertise is always something that, expertise tends to have an influence on things. So we put that there too. So, but that's just to explain the process. You have to look at what you're trying to, especially if you have some specific visualizations that you're looking at, say, for instance, that include more color versus shape. You might want to look at perceptual psychology literature to see if there are some specific abilities that are more related to color processing as opposed to shape processing. It's just that, so like another example, this idea of that we're now looking at this narrative visualizations where it's text and visualizations. We needed to include some tests for reading ability. If you remember, I was talking to you about that, right? And we needed a test. It was like, oh, this is going to be easy. We'll just go and ask people doing reading research to give us a test. The problem is most of these tests are very long, so half an hour, and we couldn't afford that. And so we spent a lot of time trying to find ways to test for reading ability without taking, half of the time that we had. And
Vocabulary is a good one.
which one? Vocabulary. Yeah, I think that's one. Yeah, the one that we use, and there was one with his pronunciation. So we used two, and then we just correlated the measures, and yeah. So, but I'd be happy to talk to you. You can show me the differences that you're looking at, and because we grapple with that problem all the times. So, but these studies, I see them as exploratory. So the more the more user characteristics you can put in there that make sense, the more information you get from one study, right? On the other hand, you don't want to overload your analysis. You don't want to overload your, actual task study time. So, but it's a good question.
Or the adaptations that you would need to test afterwards.
Sorry?
Or the adaptations that you would need to evaluate afterwards.
Well, but you could always say, well, I see these are the results, and then I could start working. You don't have to attack all of them, right? You could say, I could just focus on one and just see what happens there, right? So, and I just remembered that I didn't answer one of your questions. Of the individual differences, I don't remember. I would say probably perceptual speed always has a pretty strong one. But for the second study, I think both spatial, the two that I mentioned have pretty medium effect sizes. So your previous question was related to, the microphone, yeah. But does it make, yeah, it does work. So the other question that you were asking is why hiding for customization, right? So it's something that, first of all, you want to see. So it's true that in itself doesn't always work, right? However, it is possible. So because of the nature of the problem, you can still make decisions based on only one visualization, right? The two visualizations enrich each other, but you can still, you still have all the information in either one, okay? So potentially they could still evaluate the scenarios and rank them based on only one of the two, okay? But having two actually makes the whole thing richer, right? But we just figured suggesting to hide one could be a way to facilitate. So the real reason why we went for that, it was an easier way before getting into what kind of support you provide for each of the two, okay? Because we didn't do that, we haven't done that step of doing the detailed analysis of gaze patterns to understand where is it that they might need help, right? And we didn't really ask them, because these are things that I don't think you can get out of interviews. So that's something that was like, we wanted to try, and we just wanted to see if, even in terms of, a possibility, and actually some users that customized did better because they customized. So we do have measures of performance, and we did an analysis showing when customization was useful and when it wasn't. So for some users, removing one of the two was useful. So that they just like to, whatever it is, as long as it's useful.
Sorry to interrupt. Unfortunately, we're out of time again. This is a very interesting topic. I can see there are still people with questions that we didn't get to. So Cristina will be around after the panel session that's happening now with Danielle on it. And I'm sure Vishy will be happy to talk to you. Thanks, everyone.
Thanks for coming. Thank you.